Hello everyone, it's my pleasure to introduce Slicing and Dictionary, a new approach to medical big data. Continuous updates to medical databases increase observations and variables, significantly expanding individual data files, evident both in the growth of row counts and the expansion of column counts. For instance, Mimic 3.0's chart events file has hundreds of millions of records, while ELSA's first-round core file includes just 1,099 records but 4,484 variables. Large-scale databases like these pose challenges in querying, cleaning, and processing. Common data acquisition methods are SQL queries and distributed storage conversion. SQL queries are versatile but have high learning thresholds and low efficiency. Distributed storage conversion is scalable but costly. Neither suits most clinical researchers. To address this paper proposes an innovative slicing plus dictionary data processing strategy. It aims for flexible, efficient extraction of medical big data to enhance accessibility and practicality. This study designs a multidimensional data slicing strategy for diverse clinical research needs: clinical dimension slicing, dividing data by parameters like vital signs, tests, and medication; event dimension slicing, building views around key events such as intubation, medication, and surgery; and hybrid dimension slicing, combining features into composite slices for complex analyses. The dictionary system bridges user queries and data slices. Its key elements: a coding description location attribute structure with standard coding, clinical description, data location and attributes per entry, a multi-level classification system hierarchical by clinical fields, parameters, and measurement methods, synonym mapping for unified term retrieval across terminologies, and cross-database compatibility to map identical clinical concepts between databases. It lets researchers use standardized terms for data retrieval and analysis. Slicing is divided into vertical and horizontal types based on the direction of data segmentation. Vertical slicing is suitable for long-format data where volume is dominated by row count, records grow with database updates while variables remain stable. For example, Mimic's chart events file has fixed fields but expanding records over time. Horizontal slicing works better when data volume is driven by column expansion, with few record changes but a large number of variables. Datasets like ELSA surveys fit this, with limited samples but massive variables. In ultra-large datasets where both rows and columns affect size, combining vertical and horizontal slicing enables more flexible, efficient storage and querying. Here we can see two typical data forms. The purple long data stream at the top represents data like that in the Mimic database, which contains hundreds of millions of records but has a basically fixed field structure. The blue wide data stream at the bottom corresponds to complex data with thousands of variables in the ELSA survey. These two data characteristics are exactly the key technical barriers that clinical researchers need to overcome. Our innovative solution is like equipping data with an intelligent navigation system. First, we perform precise slicing. For long data, we implement row slicing to decompose massive records into manageable blocks. For wide data, we carry out column slicing to break down thousands of variables into variables. In this process, we have specially designed an intelligent dictionary system, which acts like a translator for clinical terms, automatically mapping professional terms such as white blood cell count to specific blocks or variables. When researchers need to analyze specific indicators, the system will accurately locate the relevant data blocks. For example, when querying white blood cell count, it only needs to process block 1 without scanning all the data. Finally, the system automatically integrates data from different sources and outputs a structured table containing a variety of key indicators. Summary: this system integrates multi-level clinical slicing and a standardized dictionary, breaking traditional bottlenecks to handle the massive expansion of medical big data. It cuts resource use, speeds up queries, allows customization, and enables ordinary devices to process large-scale data on demand. The platform supports dynamic vertical/horizontal slicing and cross-database compatibility, fitting scenarios from single disease research to multimodal analysis. Its interface lets clinicians operate with medical terms, not SQL, lowering technical learning costs.